So it looks like there was a little bit of a blip in the audio there, and that got cut off. So just to clarify what I just said, so any of the coefficients or the constant term of a linear equation is allowed to be any real number whatsoever. Okay, so now let's take a look at a couple of or a few examples of equations that actually fail to be linear equations. So here's an example right here. We've got x plus 3y squared is equal to 0. So that's an example of an equation. It's certainly an equation in the variables x and y, but it's not a linear equation. And the reason is just simply because the variable y has an exponent of 2 on it, and that's just not allowed. That's not allowed for. If you take a look at the general form of a linear equation, you see there's no room for exponents on the variables. You can, however, have exponents on the coefficients or the constant term. That would be no problem, but we can't apply an exponent to one of the variables. Okay, and the second example here, uh, sine of x plus y is equal to pi. That's not a linear equation either. Now the pi as a constant term on the right-hand side, that's no problem because pi is still a constant, but it's the sine. It's the sine function which has been applied to x. That's what makes it not a linear. It makes it not a linear function. Okay, and in our third example, we've got the square root of u plus 2v plus 3w. That's an equation in the variables u, v, and w, but it's not a linear equation. And the reason for that is just because there's a square root on the variable u. Just like we can't have exponents, we can't have radicals either. So that's an example of an equation in u, v, and w, but not a linear equation.